Oh, okay. Number 7. Let's see. Data here. Number 7. I don't even know what number 7 is. Oh, I got him right here. Look at this other one. I see. Okay, so it says the dimensions, or box has dimensions 5.3 meters by 4.8 meters by 6.7 meters. Find the volume of the box in cubic centimeters. So there's 2 ways you can do that. You can start by converting each measurement into centimeters at the start and then multiply them out. Or you can take your volume in cubic meters and convert that into cubic centimeters at the end. Either way will get you the right answer. I think sending each measurement to centimeters at the start is the way that is less likely to result in a mistake. So for example, I know that 1 meter has 100 centimeters in it. So my volume becomes, if I convert all of those, it's just basically multiplying each of them by 100. Whatever centimeters cubed. Now, if you had done it after, so if your volume is some like whatever meters cubed, to change that into centimeters cubed, I have to multiply by 100. Cubed, though, 1 over 100 centimeter, or 100 centimeters over 1 meter cubed, because the unit has to match, right? So that's the part that's easy to screw up. Why I think it's easier to just convert them to centimeters at the start and then multiply it out. Less likely to make a mistake there. Is that good enough, Luca? And they have the correct answer sitting in front of me, so. But I figure this is sufficient, right? Okay. Anybody else? All right, cool. It's filled. All right, so today begins our journey into statistics. This will occupy the majority of the rest of first semester. Will be these statistics ideas. So when we're doing this, when we're doing these statistics, definitions are going to be very important. There's going to be a lot of terms that need defining and like talking about what things mean, and like that'll be necessary for how do we interpret results. And then calculator competency is going to be super important. Almost nothing that we're going to do for the rest of first semester is going to be done by hand. Now, I'll show you the by hand, but largely the calculator is just going to take care of it for us. Okay? Reese. We'll talk about how we would actually do that. And we actually won't get into. Hi!
Hello.
How are you?
So good, how are you?
I'm happy as a clam. Charles. Is that you, Henry?
That is me.
Okay. You have a happy birthday card. Is it your birthday today?
It is.
Oh man, happy birthday.
Thank you.
17 or 18?
18.
Go register to vote here, my friend. Pick up a pack of cigarettes.
I'll go gamble with Mr. Davis. Sorry, you.
Okay, there you go. That'll be fun. All right. So keeping that in mind. Now, this first chapter or so is going to be foundational ideas. We're not going to be doing a ton of calculation here. But as we go on, like having our graphing calculator with you every day, I think will be really helpful so that you can follow along, and I can help show you how to find the commands on your calculator and be able to do that. Okay, today though, it's going to be mostly just vocabs. All right. So we're talking here today about data analysis, which is part of the field of statistics, which is just the science of data. To analyze the data, though, we're going to organize, display, summarize, and ask questions about it. It's part of the data analysis process. So the place the data is coming from, or what the data is describing anyway, is a population. So that's where you're pulling your data from. So like we have an election coming up around the corner. One of the things they'll do is polling. They'll try to see like who do they think is going to win. So the population, so they call up individuals and ask them about how they're planning on voting or what their feelings are about this, that, or the other. The population is the set of peoples that are on like the to-call list, whether we're doing a survey of Michigan residents or national residents. The population are the people we end up calling. And the variable is it's like whatever we're trying to learn about. So if, again, we're doing like a political poll, it would be, we're trying to learn about your voting tendency, right? So we maybe want to see if like, how the richest segment of the population wants to vote. Like that could be the variable, right? So we'll call up a bunch of wealthy voters and ask them what their feelings are on the candidates or something. Now, that variable that we're looking to analyze can be two types. You can have a qualitative variable, so something that's not numeric, or you can have a quantitative variable, something that is numeric. So example of a qualitative variable might be, like, what is your feelings about this, that, or the other? You can be like, agree, strongly agree, neutral, disagree somewhat, or strongly disagree. Like, that's a qualitative question. Or it could be like, what's your favorite color? Or what's the best, what's the best song on the radio? Or something like that, where the answer is not numeric. Just like it's a category still, but it's not a numeric thing. Quantitative data would be something that is numeric. So maybe we're looking at, the average height of, like high school basketball players who sign a Division I letter of intent or something. Like that's a numeric, you're looking at a height, a number. Everybody's okay with that? Or like the average GPA of, the acceptance at the University of Michigan or something. Like, again, it's numeric, that's quantitative. Again, the root word there on qualitative is quality. As quantitative, it's quantity. Like quantity is a number, it's like how many. Quality is like a description, it's a word. That's how I remember it. You have two major types of quantitative data. Those are discrete and continuous. So an example of a discrete data, you might look at the number of children in a household. So if you call up somebody and you ask them how many children live in their house, that's going to be a discrete answer. You can have 3 kids or 2 kids or 1 kid or 12 kids, but you can't have 3.65 kids, right? If you look at, weights of, NFL linemen, that's a continuous data, because depending on how accurate your scale is, you can have someone who weighs 300 pounds. You could have someone who weighs 301.2564221 pounds. Like weight is a quantity that can be continuous because just depending on how accurate your scale is, we can measure you down to the weight of an electron if we really wanted to. But who cares? Everybody okay with that? Okay. And then worth noting that qualitative data can only be discrete, right? You're only going to get decided chunks. Think about if you ask for a favorite color, you can't have something that is, it's red and a half. What? It doesn't even kind of make sense to think about it that way. So typically when we do some kind of a survey, our variable is going to take on lots of different values. And often we're going to be interested in sorting that variable to see how many times it takes on each value. Doing that is called a distribution. So, for example, we have a survey of gas mileage for different models of vehicles. So our variable is the miles per gallon. And one way we could draw the distribution is using what's called a dot plot. So we just write down the different miles per gallons on the x-axis and we put a dot above that miles per gallon each time there's a car in our data set that has that miles per gallon. So that's an example of what a distribution might look like. So that it's often going to be a graphical representation. Okay. So again, this is our same miles per gallon data set. So if we want to study the relationship between the variables, typically what we do is we start with a graph, and then we might do some kind of numerical analysis. So this is from my graphing calculator. What I've done is I've calculated the mean miles per gallon and the standard deviations and things like that. And that adds another layer of analysis we can do that's more than just visual, looking at it. But the visual distribution can often give us a lot of information as well. The numeric one is nice because this is a little bit more precise and let's say almost more valuable. It has more meaningful analysis you can get out of the number than you can from just a picture. So often what we're doing in statistics is we want to go from our data analysis, we've gone and we've collected some data, we've graphed it, we've done some statistics, we've gotten some result. Now we want to be able to say something about that data set. So that's called making an inference. So we start with some population that we want to study. We're going to take a sample from that population. We're going to collect data from that sample. We're going to then perform some kind of data analysis on that sample. And then based on that data analysis, we can make an inference about the entire population, right? And again, election coming up, this is exactly what they're trying to do with political polling. You try to take a sample of Michigan that's a reasonable representative sample of Michigan residents, try to feel like how this, how your sample feels about, the coming election, make some inference about how you think the state of Michigan as a whole will vote. Everybody's cool? Again, like we're just kind of building some vocabulary out, laying some groundwork. Nothing technical here. So again, talking about this data collection piece. So again, the population, again, is the entire group that we want information about. We use a census or a study to collect data from we can use a census to collect data from every individual in the population. Now, this is very expensive, right? If you're talking about like millions of individual data points, like to do a complete census is really, really expensive. That's why the government does a census of the United States. I think it's every 10 years we do a census, because it is like, it's very time consuming. You have to pay a lot of people. You create a ton of data to analyze. Now it's really valuable, but it's very expensive to do. As opposed to a sample where you take a subset of the entire population and we collect data from that. And there's a variety of ways in which you might create that sample. But the goal is usually looking for something that's pretty representative of the population as a whole. So almost never do we do a full census when collecting data. Like imagine you are, General Motors, and you're looking to look at how, or the rate of defect in your vehicles you're producing. A census would be looking at every single vehicle that comes off the line and analyzing every single one for defects. Unrealistic to do that. It'd be enormously expensive and time consuming and like really slow down your production. What you probably will do is take every 100th car or something and analyze that and look for defects and, infer that what the rate of defect that you're seeing in your sample is the same as the general population. So we say a parameter is a numerical characteristic of a population, and a statistic is a numerical characteristic of the sample. So again, like, like if we use our cars example, the parameter would be the actual rate of defect that you found by doing a census. Your statistic will be the rate of defect you found from the sample, right? It's a numerical characteristic, like, like the average car has like 1.3 defects in it or something. Okay. So when we talk about statistics, what we're often most interested in are inferential statistics. So that's something you can make an inference from. So once again, we have our population. From our population, we'll take a sample. We'll collect representative data from that sample, and then make an inference about the entire population. So let's talk about how we're going to be doing that data collection, or the different ways you can do that data collection. So the first is going to be how to choose your sample. So the goal is you want a representative sample. You want your sample to basically have all the same attributes as your general population. So if you're doing a political survey, you'd want your sample to have like the same like political leanings as your population. So you'd want like the same amount of right and left wings. You'd want the similar educational background. So you'd want the same percentages of like, non-high school graduates, high school graduates, college graduates, etc. You'd want the same like economic distribution. So you'd want the same amount of like, low, middle, and high income individuals. You'd want to try to craft that sample so it looks the same as your overall population. That's really difficult to do in practice. So again, to pick your sample, you want to start by, well, what are we trying to measure? What are we trying to make an inference about? What's the actual population? If the population is voters, then our sample shouldn't include anyone that's under 18, right? Or anybody that can't vote because they have like a felony conviction or something. So you want to make sure that when you're defining your sample, it's just not Michigan residents. If it's going to be voters, we want voting eligible Michigan residents. So they have to be like legal citizens and not here on like a work visa or something like that. And then you'll want to decide what exactly you want to measure. So if I want to measure, like their party affiliation, that might be different than how they're actually going to vote, right? Like depending on what I'm really trying to measure would dictate like, like how I want to construct that. And again, so say we wanted to look at like, okay, like this political party is trying to make inroads in marketing to this specific demographic. Maybe we want to do a better job targeting like, suburban, non-college graduate voters or something. Well, then if that's what you're trying to measure, the population, like really narrows down as to how, like who you're going to try to collect data from, right? Like you don't want the rural millionaire in there. Or I should say the rural professor. And then you decide how to choose the sample from the population. And that actually has a big impact as well about how you actually pick the individuals that are going to go into your sample. So the different ways to sample. One type is random sampling. This is kind of the gold standard of sampling. In practice, it's incredibly difficult to do unless you already have like a census style data set to pull random individuals from. But if you're trying to like poll voters, really difficult to get a truly random sample and still maintain like a representative your representative demographics, because if you're just calling random individuals, that's not going to get you representative, because who are you calling? Like you got to have a phone, you have to have a listed phone number, like there's a bunch of things that, like you have to have the time to answer the phone. You have to be willing to answer your phone, like many people just don't answer their phone at all. So it's really hard, like in practice, to get a truly random sample and still maintain, representative demographics without like a census style data set that you're just randomly pulling. Easy to do if you're looking at miles per gallon for cars, right? Here you're just looking at whatever the manufacturer published. Much harder if you're looking at, like a population of living organisms. So the one type of random sampling is called a simple random sample, where you have weighted each individual equally inside of your population, and you just have like a 1 in, if there's n individuals in your population, each person has a 1 in n chance of being selected. And to do that random sampling, often you can use like, a random number generator or something like that to do that. It's not just like, it could be the same thing as like pulling names from a hat. That'd be a big hat if you're talking about millions of individuals. Okay, so to do this, what you would do is you take your list of individuals, you assign them each a number from 1 to n, and then you use some random number generator to select a number from 1 to n. And whoever number it calls is the person that goes into your sample. And if you want 100 individuals, then you'll do that random number generator 100 times. And you can set it up to do it like without replacement. So like once you've called number 97, it won't output, the random number generator can't output number 97 again, kind of thing.
Like how many people would you do that out?
It depends on a lot of things. So ideally, if you had infinite resources, you would do a census and you just survey every single individual. Now no one really has the resources able to do that because, in a political polling situation, like time is a big one. You don't have like 5 years to do this, complete this, and then look at the data because your election is over 4 years ago. So it just kind of depends on how much money you have, how much time you have, what quality of a sample. Like the more individuals you can sample, usually the better. But for some statistical analysis, you can't have too many individuals. Like you might not want more than 10% of the total population in your sample. Some statistics have requirements like that for the validity. So it just kind of depends a little bit on what you're trying to accomplish. In theory, you would just want a census and want every, information on everything, but that's often not realistic. Sometimes, again, so a simple random sample is, like, in theory, it's easy to set up. In practice, it's often hard to execute. Like you set up a simple random sample for political polling, and you draw like John Smith, and John Smith just will not respond to your phone calls, will not answer his door. Like, you can't find him. His address, he's like moved 6 times, and you can't figure out where he actually lives anymore. Like, he's a person with a social security number, but you just can't locate this guy because he's just like in the wind somewhere, And then it's like, what do I do now? Like, do I just still keep hunting? Like, you're supposed to just still keep hunting this guy down, but like in reality, like, well, because it like changes the. So now your population doesn't include John Smith, right? And every time you take like somebody out of the population, like now, okay, so we're doing this for all Michigan residents except for John Smith. And you do that a bunch of times, and you no longer are talking about your Michigan voters anymore because you've removed like just the people you couldn't locate. Those people are probably still going to vote. Like, it hurts the reliability. You know what I mean? So like probably in practice, 1 or 2, like a couple of these, not a big deal. But when you do this in practice, you're talking about surveying thousands of individuals. Like for political surveying, I think the rate of response on anything is like 5%. So like kind of ruins what you're trying to do if you're doing a simple random and you just keep discarding people because you can't find them. Does that make sense? Okay. Another type of random sampling is called a stratified random sample. So what that means is you're going to classify your population into strata, so like groups based on some demographic information. So if you're doing political polling, maybe you want to create strata for like Republican, Democrat, Independent, and make sure that the random samples I'm pulling from these match the ratio in the general population of Democrat, Republican, and independent. Does that make sense? So maybe you want like 45% to come from this, 47% to come from here, and everybody else comes from there, so that when you look at your sample, it matches that demographic in particular for the whole population. If that's, like one of the things you're really learning or wanting to study is like how these different, like party affiliations affect, feelings on, immigration or the economy or foreign policy or whatever. So you might want to do something like this. Again, you run into the same problem with your random sampling, especially for a political poll, where sometimes it's really difficult to get a hold of people to ask them about it, or they just flat refuse to answer your questions and you can't make them do it. But it's the same kind of setup as after you've made your strata, you do like a random sampling inside of each strata based on, the ratio that you want inside your sample of each strata. Okay, another type of sampling is called systematic sampling. This is different from random sampling. And the advantage here is often that it's way easier to do. So a systematic sampling, we're going to start by just determining how many individuals are in our population and how large we want our sample to be. And then we'll calculate a number k. So we'll take the whole population divided by the sample size, and that's our value k. And we'll round to the whole number. And then from our sample, then we're just going to pick every kth individual. So similar to, like the production line sample, where we're just going to sample like every 100th vehicle or something. So another type of sampling is doing what's called cluster sampling. So like, again, if you go to the political polling, you might go to like, a concert or a sporting event or an outdoor festival or something where there's a lot of people, or just to your local shopping mart, and just like ask every seventh person that walks out the gate your survey question or whatever. So another one is cluster sampling. In general, this is massively cheaper and easier to do. So you start by clustering individuals based on geography, things that are located near to each other, and then do a simple random sample inside of those. So instead of having to travel all over Michigan trying to track down your individuals, it's like, well, we're going to take, like a east side urban and east side suburban, east side rural, west side suburban, west side rural, and we're just going to survey from some people from a Grand Rapids neighborhood, you get the idea, right? Like we're going to separate this often by geography. And the advantage there is like from the person collecting the data, it's just way less travel. So it's cheaper, takes less time. But you have to be a little bit careful about where you're pulling your sample from. And are these like really representative areas? So it's hard. We've seen that it's kind of really hard to create a good sample in practice. And we've seen what I've talked to you now about kind of what good sampling might look like. Let's talk about what bad sampling might look like. So one way in which it's really easy to get results, but often the results aren't that great as if you do something like a convenience sample. So like, let's say we send out our political survey to every Michigan resident. We get back 13,000 of them. Everyone else just throws it in the garbage or doesn't respond or whatever. That's a convenience sample if we use that 13,000 to just make an inference. You guys get the idea there and what we mean by convenience? Now, in some cases, you just have to do it this way. Like you just don't have the budget to do something different. But it's like not, you wouldn't like to do it this way, right? And if you're doing something that really matters, like if you're trying to, look at, like if you're the FDA and you're trying to green light a medicine and checking if it has, like side effects or, if it actually works, you definitely don't want to do any kind of convenience sampling because if you're wrong, like people get hurt. Political polling, if you're wrong, nobody really gets hurt. So convenience sample there is kind of acceptable. If you're looking at, defects in like airplane, that's something where you don't want to be wrong because if you're wrong, like people really get hurt, right? Like, so that's, some places convenient samples fine. If you're sampling like who prefers Frosted Flakes over Cheerios, like if you're wrong on that and nobody's getting hurt, it's okay to do kind of a convenient sample there, or more acceptable anyways. And the reason why the convenient sample is, like not a great way of doing this is you often get unrepresentative data, i.e. you've introduced some kind of bias. Like the people most likely to respond to a political survey are probably the people who feel, most strongly about a particular candidate, in the upcoming election. Like you kind of like putting your thumb on the scale, so to speak, of who's willing to respond. Or even like if you're responding, maybe you're someone that's more likely to be home. So you're probably more likely to be a retired person. So you're oversampling, like a specific age group, or a specific income level where you have more time to be at home or whatever because you're retired and like at, 45 or something and you have a bunch of time and you're more willing to answer something like that. So there's lots of reasons why you could overrepresent, one part of your population than another by doing a convenience sample. When that's done, it's called bias, right? You have some unrepresentative sample. That unrepresentativeness is called bias. Another type of convenience sample is voluntary response samples. That was an example you already gave where like we send out the political survey to everybody, whoever bothers to send it back, that's our sample. And again, the person that's most likely to respond are the people that feel the most strongly, which again is often not representative of the entire population, right? Another type is like of bad sampling is called a quota sample. So this is like the non-random version of the stratified random sample. So you create your strata just like you do before. Then you gather from each strata in some non-random fashion, so like a voluntary response survey. And you keep sending those surveys out until you've collected, like the desired number of responses. So that would be like an example of this quota system where it's like I need to have 1,000 responses from each of these 5 strata. I'm just sending voluntary response surveys to individuals in those strata until I get 1,000 responses from each of them. I'm just going to keep flooding it and just waiting for stuff to come in. I figure if I bother people enough, they'll send something back. anyways. So the goal here in all of these, so we collect some data from it, we create a sample and collect some data from it. And the collection methods can be great or not so great or somewhere in between. And we analyze the data in order to draw an inference that we hope that applies to the entire population. And this is really why the random sampling is kind of the gold standard, because it creates the most reliable inferences, because ideally the random sampling avoids bias. And then based on the laws of probability, the inference about our population is typically pretty trustworthy, with the notion that like there's always going to be some margin of error. You know, like if we say that like, oh, 36% of Michigan residents feel this way, that could be like plus or minus some percentage, right? That's what we mean by margin of error. And then again, with most things probabilities, if you have a bigger sample, you can have a more reliable inference, because it's less likely in a random situation to get an unrepresentative sample, right? Like, think about it this way. If you flip a coin and we record whether it's heads or tails and you do it 5 times, it's not unrealistic to get like 5 heads in a row and you're like, oh, every time I flip a coin, you get heads. Now you flip that same coin 10,000 times, very unlikely that you're going to get something that differs wildly from 50% heads and 50% tails, right? You can catch a little 5-head streak much easier than you could a 10,000 head streak. Although not impossible, I suppose. But boy, I'd like to be buying lottery tickets on the day that I saw that happen. Woo! All right. So sampling surveys. So you can also, depending on how you ask your questions, can introduce bias. So if I ask the question and I say like, do you agree that McDonald's is the worst restaurant in the world? I've created bias in answering that question because I've preloaded you to think that, like I've put McDonald's at the front of your mind here rather than like just list the worst restaurant, which doesn't introduce anything to, you know what I'm saying? So like how you ask your question can introduce bias, and that's, again, another source of error. Okay, what do we have here? Okay, so also we talked about all these things. Under coverage, so if you don't sample all your demographics, and this is often very easy to do in political polling because, the very poor are very hard to get a hold of, especially like the homeless that are technically voters. They could walk in and vote, but like tracking them down and finding anything about homeless people is like next to impossible. You have non-response. So we've talked about the elusive John Smith, who we know exists, but like nobody can seem to track this guy down. We've talked about response bias already, and I just mentioned wording of questions with my McDonald's example. And there we go. So that's section 2.1. Let's take a moment here, and I'm going to pop up section 1, and we're going to look at some examples. So I'm looking in the OneNote right now. This is at the in-class examples for 7.1. If you have your tablet open and you're like, I can't read what's on the board, like you could follow along on your tablet if you wanted to. So this says, the table below gives information about 10 random U.S. residents from a recent census. So who can tell me the population for this data set? Okay, so you would say U.S. residents, right? And I would even say, could be better if you said specifically in census data, because not every U.S. resident makes it into the census data, right? Like, there's often arguments about whether you should be counting, like non-legal residents, or even like legal non-citizen residents. So it's, like adds a little bit specificity. Probably saying U.S. residents would be fine. No, I would mark it correct. I can't speak to the AB or like the IB grader or whatever, but I would mark that correct. So what variables are being measured? And then are those variables qualitative or quantitative? Who can give me a variable? Gender. Is that qualitative or quantitative? Qualitative. Very good, because it's not numeric. What's another? Income. Qualitative or quantitative?
Is quantitative a number?
Yes. That one. Good. Anyone else? Marital status. Qualitative or quantitative? Qualitative. Everybody kind of get the picture here. You have state, that's qualitative. Number of family members, that's quantitative. Age is quantitative. Travel time is quantitative. Everybody's cool? I think I said that right. Okay. So who can describe in a sentence the individual in the first row? So this fella here. Well, I guess it's lady.
Female that lives in Kentucky with 2 family members, 61 years old, married, total 21,000. And 20 minutes to work.
Yeah, that's pretty good, right? You just basically identify, like all the data descriptors into a sentence. That'll do.
Well, the income just threw me off.
It's not a lot of money.
Yeah.
We don't know.
Threw me off.
It just says a recent census, so who knows when this recent census was. Maybe it was 1920, in which case $20,000 is a pretty big deal. You're living the good life there. Part D says, based on the given data, what inferences could you make about the U.S. population in general in regard to their gender and marital status? Are these good inferences? Why or why not? So gender and male and marital status. What could we say? So gender and marital status are the 2 variables that it's asking about. Yeah, not income.
Well, they're all married.
Females are less.
So you're trying to combine both variables at the same time. Think about them separately. So what percentage are U.S. residents, would we say, are female? Like 6 out of 10, so 60%, right? So we might say 60% female and 40% male. What percent would be married? 70, right? And then we have like 20% single or never married, and then like 10% separated. That's kind of all we're asking. Just something like real basic. You don't necessarily have to connect the 2. All right. Are these good inferences? Are these good inferences?
Yes.
No.
Sure, why? No.
It's like too small.
That's what I said.
Okay. So You say no, right? That's what you said? And your reasoning was, yeah, that's probably a good reason. Is there a way we could change our inference, say, about gender to make it a little bit better than saying straight 60% of the population is female? Or maybe you could just say more Americans tend to be female than male. That's a little bit softer of a statement. More likely that's, that could be measured to be true, although to measure it exactly, you would have to do a census. No, it's no longer an inference, it's just a fact. You guys kind of get what I mean? But yeah, the sample size where you're taking 10 people from a population of 300 plus million is not a great sampling, right? Is it too cold? Okay. I try not to get it real cold in here, but sometimes, I mean, kind of. It's flexible about how it wants to react. Well, some of the, like the A-wing classrooms don't have controls. Like we do, and ours, the B-wing is relatively responsive. I think the E-wing controls are weird because they float a little bit. Like you can change it up or down, but then it just like floats back to, yeah. So you heard it just kick off, so you should warm up here in a few minutes. All right, next example. It says in May 2010, the Los Angeles City Council voted to ban most travel and contacts with the state of Arizona to protest Arizona's new immigration enforcement law. The Los Angeles Times conducted an online poll that asked whether the city council was right to pass a boycott of Arizona. The results showed that 96% of the 41,000 plus people sampled said no. What type of sampling did the Times use in this poll? What was the type of sampling we did here? You set up an online poll and just asked residents yes or no. Yep. This is voluntary response because you flooded it to basically everybody and just waited for them to, whoever cared, send it, cared to do it, did it. That's it. Everybody's okay? Explain how this sampling method could lead to bias in the poll results.
The people who strongly agree with one side of it.
Yeah, the people that feel most strongly about it are the ones that are most likely to respond. Right? If you don't care, you're unlikely to answer. Okay. All right. Next one. A school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books arranged by type, fiction, biography, history, and so on, that are shelved on 400 shelves, where each shelf holds 50 books. You want to select a random sample of 500 books. So explain how to select a simple random sample of those 500 books.
Just like randomly choose 10 shelves.
So that won't be a simple random sample. That is a sampling method, but it won't be a simple random sample. So what you do, you have 20,000 total books, right? Each of the 20,000 books is assigned a number, and use a random number generator to select 500 numbers from that list. those are the books you choose. So it's not separated by location. Every book has an equal chance of being selected. Is everybody cool? Okay. Part B says, explain how to select a stratified random sample of 500 books. Justify your choice of strata. And let's start there. Okay, so you create your strata by genre, right? Okay. That seems reasonable, right? Probably that most, like a reference book is likely much longer than a novel, than a fiction book. That seems, like a reasonable choice. Genres probably maybe tend to be the same length. That's probably a reasonable idea. Why might the librarian want to do this method instead of the simple random sample?
So it's arranged by type.
The library is arranged by type. So to pick your fiction strata, they're just going to be on like the same set of shelves all in a row. You go to your next set of shelves for biographies, you just pick your biography so you don't have to walk back and forth across the entire library searching for one specific, like it's just less work for the librarian to actually track these things down if they're all kind of in a group. Does that make sense? Are there disadvantages to this?
A fiction book could either be 60 pages or 600.
Sure, yeah. So even doing so, you might, it doesn't really necessarily, like these books are equally likely to have similar number of pages. Sure. How about this idea? What if there's, like the section works out, so I need, 13.5% of my books need to be biographies. And that works out to be, 13.5% of 500 works out to be a decimal. Do I round up or do I round down? That's not nice either, is it? So there's another problem, right? Like getting the actual, percentages to work out, sampling whole numbers of things, it can be a little hard. Okay. Part D says how to select a cluster sample of 500 books.
Would that even be possible? Because if they're arranged by
Well, I mean, you could look at, just taking, like 10 of the shelves and randomly pulling 5 books from each shelf. Now, that's easy, right? Like you just pick out your shelf, you walk over to it, and you grab your 10 books. That'll be really convenient. Right? So making your cluster, the shelf, a specific bookshelf is a nice way of doing that. What's the disadvantage, though?
you don't really know what you're grabbing.
You don't really know what you're grabbing.
Oh, you could grab well, it's still random. When you say random, is it just random by, okay, I'm gonna grab this one, this one, this one?
Or is it always a random number generator like that?
It's kind of all, we're going to assume like it's a random number generator, but instead of like all 20,000 books possible, it's just the 50 on that shelf. How are the books arranged again? By type. So what's the likelihood that all the books on a shelf are the same type? Pretty good, right? Is it possible that you end up just pulling all fiction books? Or you omit, like, I didn't get any reference books or something? So like getting your demographics to work, it's very unlikely you'd get a representative sample by doing a cluster in this case, since we know that everything is arranged by type. You just pick, like 50 shelves of the 400, you very likely could have just like one shelf of biographies or something and get very few biographies into your sample when in all reality, 20% of the library's books might be biographies. Does that feel okay? Oh, I forgot to do this one, the systematic one. We need to do that. How would we do a systematic sample for the 500 books?
What's the systematic one?
So it's like, you remember when we talked about the assembly line and we just checked like every 100th car or whatever? So we would take the 20,000 books, divide it by 500, and like every, whatever that 400th book or something, or 40th book, you just grab it and you just go through the library. Like every 40th book, you snatch it, count the pages.
You probably check a lot of the same books because they're all organized by type.
You might, but if they're all organized by type and you're taking the 40th book, you're at least you're going to get every type, right? And if there's like way more fictions than there is everything else, you're going to still pull more fictions than everything else. Like it's going to be reasonably representative. It may not be perfect, but it won't be bad. And it's certainly convenient, right? You just like walk through the library in a row and just like every 40th book, you count the pages on it or whatever. You still have some chance of like underrepresenting things, right? It's possible if there's, less than 40 books of some type, you skip that type entirely. Like if you're looking at, books about, mathematics theory or something, the library might not have very many of those, and you might, skip all the way past something like that. So you still might underrepresent stuff. It's hard to, I think it would be hard to miss the demographics if the demographics are reasonably evenly distributed. If it's like, we just have like 10% are these, like 14% are those, 16% are these. Like that, I think you would get a pretty decent sample if your demographics were pretty reasonably distributed. But if you have a lot, like some really small ones, you could certainly miss those entirely. Okay. What do you guys think here on this? It's okay? So the vocab is really what you need from this section. We did 0 in the way of calculation here. It was just vocab. And I'd encourage you here, like the vocab's important. At one point in this semester, when we do our internal assessment, you guys are going to do your own sample. So at some point, like you're going to do these things and you're going to have to write about like what you did and why you did it. So like making sure you understand like how to do these things and like what this might look like and what are the advantages or disadvantages, so you have something to talk about in your paper. Although this seems like fairly simple and straightforward, like you're going to need to be able to talk about this kind of thing, or at least refer back So when you look at like, okay, it's time for me to actually design my sample or how I'm going to do my sampling, like I have to think a little bit about how I'm going to do that and what are the advantages and disadvantages so that I remember to talk about this in my paper. How do you guys feel? It's okay? So you guys should be, let's see, we should do that section 7.1. Let's see, that's on page 216, and it goes to 218, and it's numbers 1 through 10. I will get that into My Notre Dame as an assignment right now. When would that be due? Next Sunday at midnight. I sure hope so. If not, consult your physician. Yes, of course. Everybody happy with that? So that's going to be the 8th. And you remember that your test is scheduled for the 4th next week, right? Don't forget, because I won't have a chance to remind you, but when you, by the time you get back, right?